Have you ever wondered why iron rusts over time, or why ice melts into water? These are not just random occurrences. They're the result of physical and chemical changes happening right before our eyes. Everything we interact with, everything we touch, smell, taste, and feel is constantly undergoing some sort of change. Consider the simple act of boiling water for your morning tea. The heat changes the water from a liquid to a gas, a physical change. Or think about the process of baking a cake. The ingredients go into the oven and come out as something entirely different, a delicious treat that's the result of chemical changes. From the rusting of iron to the melting of ice, from the boiling of water to the baking of a cake, we are surrounded by physical and chemical changes. Today, we are diving deep into the world of physical and chemical changes and how they play a part in our daily lives. So, what exactly are physical changes? Well, let's unravel this mystery. Physical changes are transformations that do not alter the identity of the substance. They're like costume changes. The substance might look different, but underneath it's the same old thing. Imagine an ice cube melting in your hand. The ice turns to water, right? But it's still H2O, just in a different form. That's a classic example of a physical change. Or consider boiling water. The water evaporates, but it hasn't changed its essence. It's still that good old H2O, now merely in a gaseous state. Even tearing a piece of paper is a physical change. Yes, you've got two pieces now, but each piece is still paper. You haven't created anything new. The intriguing part about these changes, they're usually reversible. You can refreeze water, condense steam, and okay, maybe you can't untear paper, but you get the idea. Physical changes are fascinating, aren't they? But wait until you hear about chemical changes. Now, let's shift gears and talk about chemical changes. Chemical changes, unlike their physical counterparts, are transformations that fundamentally alter the identity of a substance, resulting in the emergence of a new one. Think of the rusting of iron. When exposed to moisture, iron transforms into iron oxide, a completely different substance. Or consider the burning of wood. The heat causes the wood to react with oxygen in the air, forming ash, smoke, and gases. Even the food we eat undergoes chemical changes. When we cook food, heat causes proteins, fats, and carbohydrates to react and form new compounds, changing the flavor, color, and texture. And unlike physical changes, these transformations are typically not reversible. You can't unrust iron, unburn wood, or uncook an egg. These are all examples of chemical changes. Chemical changes might seem more complex, but they are just as common as physical changes. So, how can we differentiate between physical and chemical changes? Well, the key is in the details. When we talk about physical changes, we're referring to alterations that don't affect the substance's elemental identity. Take a block of ice melting into water, for instance. It's still H2O, just in a different state. Moreover, physical changes are typically reversible. The water can refreeze back into ice. On the flip side, chemical changes involve transformations that form entirely new substances. The identity of the original substance is lost. Picture a log burning into ash. The log can't be reformed from the ash, signifying its irreversible nature. Most importantly, observe the signs. A sudden change in color, the release of light or heat, or the formation of gas or solid are telltale signs of a chemical change. So, the next time you see something changing, ask yourself, is it a physical or a chemical change? In a nutshell, both physical and chemical changes are integral parts of our lives. They constantly shape and reshape the world we perceive. Physical changes, remember, are all about transformation without altering the substance's identity. It's like changing clothes. The person remains the same, but the appearance changes. On the flip side, chemical changes are a bit like a magic trick. They involve a substance transforming into a completely new one, just like a magician pulling a rabbit out of a hat. It's not just a change in appearance, it's a change at the very core. The key to distinguishing between the two lies in identifying whether the substance has retained its original properties or not. If it has, it's a physical change. If it hasn't, then you're looking at a chemical change. Remember, every change you see around you is a testament to the fascinating world of physical and chemical changes. So keep observing, keep learning, and keep exploring.